All right, guys. Can you still hear me?
Yes, we can.
All right, good. So we'll go ahead and get started. Can you all see my screen?
Yes.
Great. All right. So before we, so please, can you guys mute yourself? Unless you have a question, please mute yourself. All right. So before we get started, I would like to remind you guys that we have our first project that is due this Sunday. So because we have not been able to meet in person since our last meeting in person, I am going to allow you guys, for those of you who have not formed your groups yet, I am going to allow you to work on this project individually in case you do not have a group. But if you have already formed your group, you're welcome to work on this project as a group. And remember, even if you work on it as a group, you will still have to submit the project individually in Canvas. So in other words, every single one of you guys will have to submit the project in Canvas. So even if you work on the project as a group. So I'm going to allow you guys, for those who do not have groups as of now, you're welcome to work on this on yourself, by yourself. And moving forward starting from the second project. So the next time we meet in class, I'm going to make sure everyone has a group so that you can work on the second project as a group. Is that okay with everybody?
Yes, thank you.
All right.
Yes.
All right, great. Okay, so we did not meet on last Tuesday, so I asked you guys to read about section 1.4. In that section, that section discussed the different types of biases that exist in statistics. It was a pretty self-explanatory one, so I'm pretty sure it was easy to follow and understand. So in case you have any questions about that section, please feel free to send me an email with your question. All right, so today we're going to move on to section 2.1. In this section, we're going to discuss graphical summaries for qualitative data. So in this section, pretty much what we're going to do is to look at different tools, tables, charts, and graphs that we can use to organize and then describe qualitative data sets. So with that being said, let's look at the objectives that we're going to cover in this section. There are three main objectives to cover here. The first one is going to let us learn how to construct frequency distributions for qualitative data. And then we would also learn how to construct bar graphs as well as pie charts. All right, so if you recall, the third step under the investigative process of statistics says that we have to describe the data that we have collected in the second step. And this data would help us answer the question that we have formulated in the first step. So right now we are now at the third step of the investigative process of statistics, where we would learn different methods that would allow us to describe, summarize, and organize qualitative data. So here we're going to focus more on qualitative data sets. All right. So with that being said, let's look at what a frequency distribution is. So let's see how we can construct frequency distributions for qualitative data. So before we can talk about a frequency distribution, it is imperative that we discuss what we mean by frequency. Remember that qualitative data is that type of data that puts the data values into different categories. In other words, we call this type of data categorical data. So this data set comes in different categories. All right, so now when we talk about a frequency of a category in a qualitative data set, all we are referring to is a number of times that category occurs in the data. In other words, the frequency tells us how often a particular category would occur in a data set. All right, so what do I mean by this? Let's look at a quick example. Let's suppose that I would like to collect data on the gender of students in this classroom. So what I would do is to focus on 10 students in this classroom. So I'm going to collect the gender for 10 students in this particular classroom. So let's suppose that the first student is a male, and then the second student is also a male. The third student is also a male, The fourth one is also a male. The fifth student is a female. And then the seventh student is also a female. The eighth student is a female. The ninth student is a male, as well as the 10th student. So what I have here, this would be a data set, right? And this data set, as you can see, this is going to be a qualitative data set because this data puts all the data values into different categories. So if you look at the data, there are two categories in this data. The first category would be the category male, and the second category would be the category female. So now, how many times does this category occur in the data set? So it occurs 7 times because there are 7 males in the data. So here, I'm going to have 7 to be the number of times the male category occurs in this data set. And the number of times that the female category occurs would be just 3 times. So these numbers we have here are simply what we refer to as the frequency of each of these two categories. So in other words, the frequency of the male category is going to be 7, and the frequency of the female category is going to be 3. So the frequency again tells us how often or how many times a category occurs in a qualitative data set. So that is the meaning of frequency. All right. So now with that, we can now expand this to what we refer to as a frequency distribution. So a frequency distribution is just a table that presents the frequency for each category. So what do we mean by this? So what we mean by that, if we should put all of this information right here into a tabular form, then that table is simply called a frequency distribution table. So let's suppose that we have a table. So the first column would be the gender column. And then the second column is going to be the frequency column. So the second column here will be frequency. So the gender is going to be our variable. All right. And this is a qualitative variable. So, and there are 2 categories for this variable, and the categories are male and female. And the frequency for male category from the data set is going to be 7, and then that for female is going to be 3. So this table you see right here is what we call a frequency distribution table. So the frequency distribution table simply presents the different categories of a qualitative data set with their respective frequencies. Is that clear? So if you have any questions, feel free to type your question in the chat, or you can unmute yourself to ask your question. Okay? All right. So that is a frequency distribution. Like I said, it presents the different categories of a qualitative data with their respective frequencies. All right. So let's look at another example where we have to construct a frequency distribution for a qualitative data. So let's look at this example right here. So a retailer accepts 4 types of credit cards and lists the types used by the last 50 customers as follows. So what we have here is a data set. What we have here right here, this is a qualitative data set because the data values or the observations in this data are all non-numerical, and we cannot assign numbers to these data values. So this makes this a qualitative data set. So before you go ahead to summarize or describe any kind of data, you would need to determine what type of data it is, whether it is qualitative or quantitative. So the methods that we're going to learn in this section are only applicable to qualitative data sets. You cannot apply these methods to summarize quantitative data. All right, so that's the first thing you need to do. The first task you need to perform is to determine the type of data that you are working with. All right, so obviously this is a qualitative data set. And in this data set, there are 4 categories. The 4 categories are going to be the 4 types of credit cards in this data. All right. And the credit cards are Discover, Visa, American Express, and then MasterCard. So these are the 4 different categories that exist in this qualitative data set. So the goal of this data, the goal here is to construct a frequency distribution for this data set. So that means we have to come up with a table that presents the different categories with their respective frequencies. So I'm going to go up here and construct that table. So I'm going to have the first column of the table. I'm going to call that the type of credit cards. All right, this is our variable right here, the type of credit card, and this is a qualitative variable. So type of credit card, that is going to be the first column of our table, and the second column is going to be the frequency for each type of credit card. In other words, that would be the frequency for each category. So remember, the type of credit cards are just the categories in this data set. And the credit cards that are present here are going to be MasterCard. So that is the first type of credit card we have. The next one is going to be the Visa card. The next one is the American Express. And the third one is going to be Discover. So these are the different categories that are in this data set. All right, so now to come up with the frequencies, what we have to do is to go into the data set. So when a data set is presented to you like this, we call this a raw data set. It is raw because you cannot easily make meaning out of this data unless you put it in a very presentable form or in an organized form. So this is the raw data. And all the data values you see in here, we also sometimes call them observations. So if you hear me mentioning observation all the time, I'm simply referring to the individual data values in this data set. All right, so we want to come up with a frequency of MasterCard. In other words, we want to know how often or how many MasterCards are in this data set. So we have to do that by counting. And this is where you want to pay attention and to be very careful because you want to make sure you count and get the right number. So let's go ahead and start the counting. So I'm going to have 1 right here, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So there are 11 MasterCards in this data set. That means the number of times MasterCards occur in this data set is 11, and that would be the frequency for that category, MasterCard. And then we would repeat the same process for Visa. So we would go back to the raw data and count the number of times Visa occurs in the data set. So we're going to have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So the frequency for this category is going to be 23 because there are 23 Visa cards in the data set. So I'm going to have here 23. All right, the next card is going to be American Express. So we're going to go back to the data and count the number of times American Express occurs in the data set. So we have 1 here. We got 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 American Express cards in the data set. So that means the frequency for this category is going to be just 9. So I'm going to have 9 here as a frequency for American Express. And then Discover, you go back to the data and then do the counting again. So we got here 1. We have 2, 3, 4, 5, 6, and then 7. So there are 7 discover cards in the data set. So that means the frequency of discover is going to be 7. So once you're done, you need to find the total frequency. So if you add all of these frequencies together, that should be the total frequency, and that should give us a total frequency of 50, and that should correspond to the number of customers that was mentioned in the problem. So this table we have here, this is going to be a frequency distribution table. That is what we have here. So what we just did is to construct a frequency distribution for the credit card data set. So if on the exam I ask you to construct a frequency distribution for qualitative data, this is exactly what I need you to do. Are there any questions at this point? Is everybody good?
No, thank you.
And
All
what
right.
did you say? It was you asked us on the test to assemble, what'd you say again?
So what I said is if I ask you on the test to construct a frequency distribution for any qualitative data set, this is what I want you to do. The table you see on the screen right now, that's the table I want you to come up with.
Okay, perfect. Thank you.
You're welcome. Any other questions? All right. So let's move on. So this is the frequency distribution that we just constructed for the credit card data sets. So that corresponds to what we have up there. So this is very easy to do. Just make sure that you take your time when you do the counting, especially when you have a pretty large data set. If the data is very large, you would want to take your time when you're doing the counting. Because if you get one thing, the number wrong, it's going to change everything. So please take your time when you're doing this, okay? All right. So now let's talk about relative frequency. All right, before we even get to relative frequency, I want us to see the importance of this table here. I want us to see the importance of the frequency distribution. Remember, the data set was presented to us in this form. And looking at the data set in this form, it is kind of very difficult to say exactly what is happening. You cannot easily make a conclusion about the data just by looking at it in this form. But after you organize and summarize it using a frequency distribution, you can easily tell somebody that the most frequently occurring category in this data is going to be Visa because it has the highest frequency, as you can see. That's the most frequently occurring category, and the least occurring category would be Discover. So that simply means that a lot of customers for this company prefer to use Visa card ahead of all these other credit cards. So that is a conclusion that you can easily make by just looking at this frequency distribution. And that is why it is important to organize any kind of data so that you can easily understand what is happening behind the data set. Is that clear?
Yes.
All right.
Yes.
Great. So now let's talk about relative frequency. Relative frequency is also important, especially when you want to know the proportion of observations that fall within each category. All right. So a frequency distribution displays how many observations are in each category. Sometimes we are interested in the proportion of observations in each category. So the proportion of observations in a category is what we call relative frequency. So the relative frequency will simply tell us the percentage or the proportion of observations in the data set that will fall within a category. All right. So a relative frequency of a category is the frequency of the category divided by the sum of all frequencies. So that leads us to a formula that we would use to compute the relative frequency of any category in a qualitative data set. So this is a formula we're going to use. So the relative frequency is equal to the frequency of the category divided by the sum of all categories. So for short, I usually write it as such. So I say RF for relative frequency. This is equal to F, which is the frequency, divided by TF, where TF stands for the total frequency. So that is how I write the formula in short. All right. So based on this information, let's go back to the previous problem. Let's go back to the credit card data set and let's try and construct the relative frequencies for each category in this data. So let's go back to this table. So I'm going to add a third column on this table, and that third column would be relative frequencies. So I'm going to have here relative frequencies. All right, so I'm going to compute the relative frequency for each category in this data set. So before you can compute the relative frequencies, you need to come up with a total frequency. That is the sum of all frequencies. And then you would take the frequency for each category. So we're going to go ahead and compute the relative frequency for the MasterCard category. So I'm going to take the frequency of that category, which is 11. I will divide that by the total frequency of 50. And that should give me the relative frequency of this category. So I'm going to change that to a decimal number rounded to 2 decimal places. So this should be approximately 0.22 to 2 decimal places. So this will give us 0.22. So that is going to be the relative frequency for the MasterCard category. Now for the Visa category, we're going to have the frequency, which is 23, divided by the sum of all frequency, and that is 50. So this should give us a relative frequency that is approximately equal to 0.46 to 2 decimal places. All right, for American Express, it's going to be 9 divided by 50, and that should be equal to approximately 0.18 to 2 decimal places. And then for Discover, we're going to have 7 divided by 50, and that should be equal to 0.14 to 2 decimal places. So these are the relative frequencies of each category in this data set. And like I said, these represent the proportion of observations that fall within each category. So if you consider, for example, the relative frequency of MasterCard, which is 20.22, if you go back to this raw data set, so MasterCard here covers about 22% of all observations. So about 22% of these observations will fall within the MasterCard category. That is what we mean by relative frequency. That is the interpretation of the relative frequencies. Likewise, about 46% of observations in the raw data will fall within the Visa card category, and about 18% will fall within the American Express category, and about 14% will fall within the Discover card category. So those are the interpretations of relative frequencies. All right, sometimes we prefer to have these numbers over the frequencies. And also, one way you can check to determine if you have the right numbers is to always ensure that the sum of all relative frequencies is exactly equals to 1. So whenever you construct a relative frequency distribution, you want to make sure that the sum of all the relative frequency must be equal to 1 or very, very close to 1. Sometimes because of the approximations, you might get a value that is pretty close to 1. If for some reason you have a number that is significantly different from 1, then that simply means what you have done is wrong. So there's something wrong with your frequencies here. You have to check your frequencies. So please make sure you always check to determine whether you have the right values. And also, I want you guys to note something here. When we had the first 2 columns, we called that a frequency distribution table. Now we have added a third column, which is relative frequency. So this table is no longer going to be called a frequency distribution table, but we will call this a relative frequency distribution table. So whenever you have a qualitative data presented in the tabular form, that table would always be called according to the last column of the table. So because our last column here is relative frequency, so we're going to call this a relative frequency distribution. So the name is based off of the last column of the table. Is that clear? Are we
Yes.
good?
Yes.
Great. All right. So again, if you have any questions, feel free to ask, or you can type it in the chat. All right. So that is it about relative frequencies.
So whatever you said is in that last column, so if it, like the last one, frequency, so that was the frequency distribution table. So since we added the relative frequency column, it's now a relative frequency distribution table.
That is correct. Yes.
Okay, thank you.
So you always name the table according to that last column. That's how we do
Okay,
it.
perfect.
Yeah.
Thank you.
You're welcome. Great. All right. So that is a relative frequency distribution table. So that tells us the proportion of observations that fall within each category. So that is a table right here. So by the way, I have already posted this lecture notes in Canvas. You should have these notes in Canvas. And also, this lecture is being recorded. I'm going to post it in Canvas after this lecture. So you should have access to the recording anytime. All right. So this is a relative frequency distribution for these data sets. So I believe we all know we can all do this on the exam, right? If I ask you to produce something like this on the test, you should be able to do so. Again, it is easy to do it. All you got to do is just to make sure you take your time and come up with the right numbers. All right, now let's see if we can answer this question. So I would want you guys to actually answer this one. So let's read the problem. So the following table lists the types of aircraft for the landings that occurred during a day at a small airport. So if you look at the data set, you can clearly determine that this data set is going to be qualitative data because the observations are non-numerical and we cannot assign any value to these observations. And furthermore, you can categorize the observations into different categories. So the categories in this data set would be twin, turboprop, jet, helicopter, and single. So there are 1, 2, 3, 4, 5 categories in this data set. All right, so we would use this data to answer the questions that follow. So the first question is, what is the frequency of the category single? So I want you guys to type your answer in the chat and let me know what the answer is. So I'm monitoring the chat right now. So can you guys type your answer? All right, so Alan says 10. Anybody else? What is the frequency of the single category in this data? All right. So Trip says 10, Nicole says 10. That's right. Great. Good. All right. So everybody is saying 10. So let's go ahead and check if that is right. So what we have to do is to go to the data set and simply count the number of times the category single occurs in this data. So let's go ahead and start the counting. So I'm going to have 1 right here. I'm going to have 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that means the frequency for this category is going to be 10 because it occurs 10 times in the data. The next question, what is the relative frequency of the category single? So can you guys type your answers in the chat? What will be the relative frequency for this category? Round your answer to 2 decimal places. What would be the relative frequency? Any answers? Type your answer in the chat. All right. So Stacy says 0.33. Kenna says 1/3. That is also 0.33. So correct. All right. Seems everybody is saying 0.33. All right. So let's go ahead and check that out. So what you have to do, the first thing you would do here is to come up with the sum of all frequencies. In other words, you want to find the total frequency because relative frequency, RF, is equal to the frequency divided by the total frequency. So we already know the frequency of the category single. So all we need to come up with is the total frequency, right? So that's what we need. So, and the way to do that, you would have to go to the data and count all the observations in the data set. So the first column here, I have 1, 2, 3, 4, 5, 6 observations. In the first row, I got 1, 2, 3, 4, 5 observations. So if you want to find the total, you just have to multiply 6 by 5. So 6 times 5 should be 30. So that means the relative frequency for the single category would be 10 divided by 30. That is the frequency for the single category divided by the total frequency, and that gives us 0.33 to 2 decimal places. Is that clear with everybody? Is there anyone who has a question on this?
No, you lost me when you got to once you counted the 10 single, then after that I was completely lost.
So all you have to do is just count the total number of observations in the data. So you can count everything starting from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So we have
Okay, so you that was the total of all of them together, but we just singled in on the single
yes. So
point. Okay, that's where I missed. I'm sorry. Okay, I got it.
No problem. So we're only focusing on the single category. So we are interested in the relative frequency for this category single. So that would be the number of times this occurs divided by the total, which is 10 out of 30. And that gives us 0.33. Any other questions? All right. So now let's move on. So now let's talk about bar graphs. So bar graph is also another tool that we can use to summarize qualitative data. So before we move on, I would like to say this. All the tools, all the graphs, and the methods that we will learn in this section are only applicable to qualitative data sets. They are not applicable to quantitative data. So please take note of this. So if I ask you to summarize a qualitative data, you would know what method to use. So you would use one of these tools that we are learning today. So these are only for qualitative data sets. So a bar graph is also another important graph that we can use to summarize or organize qualitative data. So a bar graph is just a graphical representation of a frequency distribution. So for example, the frequency distribution that we have up here, so this table that we have here, for example, this table, if you put this table into a graph, that graph is going to be called a bar graph because it's just a graphical representation of this table. All right, so when you convert a frequency distribution table or a relative frequency distribution table into a graph, that is simply called a bar graph. So we will see shortly how we can construct bar graphs. All right, so let's look at the details in a bar graph. So a bar graph simply consists of rectangles that are of equal width. So the width of these rectangles are the same. And each rectangle represents a category in the data. So every rectangle in the bar graph would represent one category in the data sets. And the heights of these rectangles represent either the frequencies or the relative frequencies for each category in the data. All right? So with this information, let's see if we can construct a bar graph. Sorry, is there a question? Nicole, do you have a question?
No, I'm good. I'm sorry, I didn't mute it.
All right. So with this being said, so let's go ahead and construct a frequency bar graph for the credit card data set. So because a bar graph can be constructed based on either a frequency or a relative frequency, that means we can construct either a relative frequency bar graph or a frequency bar graph. So a frequency bar graph is constructed based on a frequency distribution table, and a relative frequency bar graph is constructed based off of a relative frequency distribution table. So we will start by constructing a frequency bar graph. So I'm going to have on the side here the frequency distribution table for the credit card data set. So I'm going to have here credit card. So CC here stands for credit card, and F here stands for frequency. So the different credit cards that we had were MasterCard, Visa, American Express, and then Discover. So these are the different credit cards that were in the data set. And the frequency for MasterCard, we got that to be 11. For Visa, we got 23. And then for American Express, we got that to be 9. And then for Discover, we got 7. So this is the frequency distribution that we constructed earlier on about the credit card data set. So now what I want to do here is to construct a frequency bar graph. So in order to do that, you would draw your vertical axis, and then you would draw your horizontal axis. So the vertical axis is what we call the y-axis, and the horizontal axis is what we call the x-axis. On the vertical axis, we're going to have the frequencies for each category, and then on the horizontal axis, we're going to have the different categories in the data, and those categories are MasterCard, Visa, American Express, and then Discover. So these are the different categories. So we have to label the vertical axis according to the frequencies that we have here. So the smallest frequency is 7, and the largest frequency is 23. So I'm going to label the vertical axis starting from 0 at intervals of 5. So the next value would be 5. The next one would be 10. The next one would be 15. The next one would be 20. And then the next one would be 25. So you need to label the axis such that it's going to cover all the frequencies in the table. So now we're going to draw rectangles on top of each category, and the height of these rectangles will correspond to the frequency of each category. So for example, for the MasterCard category, the frequency is 11. So you would have to find 11 on the vertical axis, which is right here, a little bit above 10. So you would draw a rectangle corresponding to that number on top of the MasterCard category. So this is a rectangle that represents this category, MasterCard. And then you would draw another rectangle on top of the Visa category, and that rectangle should correspond to the frequency of that category. And the frequency here is 23. So 23 is somewhere here closer to 25. So that means this rectangle would be all the way up here on top of the Visa category. So excuse my drawing, it's not to perfection. All right, so that would be the rectangle to represent the Visa category. And the next one would be American Express with a frequency of 9. And 9 is somewhere here below 10. So I'm going to have another rectangle on top of American Express corresponding to 9, which is the frequency of that category. And then we have 7 to be the frequency for Discover. So 7 should be somewhere here below 9. So I'm going to have a rectangle here for the Discover category. So once you do this, so the graph that you end up with is called a frequency. So this is a frequency bar graph because it is based off of the frequency of each category. All right, so this is a frequency bar graph. So that is how we construct a frequency bar graph. Any questions here?
No, thank you.
All right. So now let's see if we can construct a relative frequency bar graph. So for relative frequency, remember, I'm going to add another column here to have the relative frequency distribution. So the relative frequency for the MasterCard category, we got that to be 0.22. For Visa, we got that to be 0.46. For American Express, we got that to be 0.18. And then for Discover, we got 0.14. So actually, a relative frequency bar graph and a frequency bar graph are exactly the same graph. The only thing that changes is the vertical axis. So on the vertical axis, for a relative frequency graph, you're going to have relative frequencies on the vertical axis. So these numbers will change to relative frequencies. So you can just change those numbers corresponding to their relative frequencies. Everything else stays the same. So once you do that, you will end up with a relative frequency bar graph. Does that make sense?
Yes.
All right. So they should be exactly the same. They cannot be different. They should have the same form of rectangles, and the shape should be exactly the same. So the only thing that changes would be the vertical axis. So you would have relative frequencies on the vertical axis if you are constructing a relative frequency bar graph. And if you're constructing a frequency bar graph, you would have frequencies on the vertical axis. Apart from that, everything else stays the same. Are we good on that?
Yes, thank you.
All right, good. So I want you guys to go home and make sure you construct a relative frequency for this data set, okay? So it's very easy to do that. All right. So now I've actually provided both graphs over here on this slide. So these graphs are the frequency. So the first one here, this is the frequency bar graph, and this is the relative frequency bar graph. As you can see, these two graphs are identical. There is no difference between these two graphs. The only difference that exists here is that over here, the vertical axis are the frequencies, and here, the vertical axis are the relative frequencies. So this one here would be the frequency bar graph, and the next one will be, so this will be the relative frequency bar graph. So that is the only difference that exists between these two. It's just the vertical axis. That's what differs. Everything else, as you can see, you can see that the height of each rectangle in these two graphs are the same. So the reason why these two graphs are the same is because relative frequencies, remember, are computed out of frequencies. That's why they should be the same. They cannot be different. All right. So now let's talk about Pareto charts. So let's see what a Pareto chart is. A Pareto chart is just the same as a frequency or relative frequency bar graph. All right, so sometimes it is desirable to construct a bar graph in which the categories are presented in order of frequency or relative frequency. So such a graph is called a Pareto chart. So these charts are very useful when it is important to see clearly which are the most frequently occurring categories. So what are we saying by this? What do we mean by this? So a Pareto chart is just a relative frequency bar graph or a frequency bar graph where the categories are presented in order of frequency. So you can present them either from the largest frequency to the lowest frequency, or from the smallest frequency to the largest frequency. So you can go either direction. So once you have a bar graph presented in such a manner, we don't call it a bar graph, but we do call it a Pareto chart. So with that being said, let's see if we can construct a Pareto chart for the credit card data set. So I'm going to, again, I'm going to have the frequency. I'm going to construct both the frequency and the relative frequency Pareto chart for this data set. So I'm going to have on the side here, the relative frequency distribution of the data. So I'm going to have the first column to be the credit cards. The second column is the frequency, and the third column would be the relative frequency. All right, so the different categories, we had MasterCard, we had Visa, we had American Express, and then we had Discover. The frequency for MasterCard was 11, and then Visa had 23, American Express was 9, and Discover was 7. For the relative frequencies, we had 0.22 for MasterCard, and then we had 0.46 for Visa, and then we had 0.18 for American Express and 0.14 for Discover. So it is 7:50 right now. So I'm going to pause here. We're going to have a 10-minute break. We will resume at exactly 8 p.m. So you guys should take a break. We'll come back and draw this Pareto chart. Any questions before we go on break?
No, I'm good.
No, thank you.
All right. So I'll see you guys.
I'm okay.
I'll see you guys at exactly 8 p.m. then. All right. All right, guys, I am back. Can you all hear me?
Yes.
Yes, sir.
All right, great. All right, so we'll go ahead and construct the Pareto charts for the credit card data sets. So we're going to construct both the frequency and the relative frequency Pareto charts. But before we do that, I want to quickly mention something right here. So when you're constructing bar graphs, I need you to pay attention here. So always you have to make sure that the rectangles do not touch each other. So there must always be some gap between the rectangles. All right. So if on the test the rectangles, if you do a bar graph where the rectangles touch each other, that is no longer a bar graph. That is something different, which we're going to learn about in the next section. So for bar graphs, both frequency and relative frequency bar graphs, you always want to make sure that the rectangles are separate from each other and there's space between them, so that you can clearly see that each rectangle represents a specific category in the data. All right, so please let's take note of that. All right, so let's go ahead and construct the frequency Pareto charts for the credit card data sets. All right, so I'm going to have here a vertical axis, and then I'm going to have a horizontal axis. So the vertical axis will represent the frequencies, and then the horizontal axis, we're going to have the different categories here. So remember, in the Pareto, the categories are presented in order of frequency. So I'm going to present the categories in order from the largest to the smallest. So that means the first category to be on the horizontal axis is going to be the Visa card category, because that has the largest frequency, which is 23. So I'm going to have here Visa, and then the next one is going to be MasterCard, that is M. The next one is going to be American Express, and then the next will be Discover. And then I'm going to have my vertical axis labeled from 0 all the way to 25 at intervals of 5. I'm going to have 0 here. I'm going to have 5. I'm going to have 10. I'm going to have 15. I'm going to have 20. And then 25. So now for the Visa category, the frequency is 23. So that means I'm going to have a rectangle on top of the Visa category, and the height of that rectangle should correspond to the frequency of the category. And then the MasterCard category has a frequency of 11, which is going to be a little bit above 10. So right here, again, make sure the rectangles are separate from each other. And the next category is American Express with a frequency of 9. So 9 is a little bit below 10. So that should be somewhere here. So I have a rectangle right here. And then Discover has a frequency of 7. So 7 is again below 10. That should be somewhere here. So I'm going to have a rectangle on top of Discover. So as you can see, you can clearly see that the rectangles are in order from largest to smallest. So when this happens, we call this a relative Pareto. This is a frequency Pareto chart. So this is a frequency Pareto chart. All right. So the reason why this is important is that it allows us to see very clearly and very easily which category occurs most frequently in the data and which category occurs least frequently in the data. So as you can see, if you look at this graph, you can clearly see that the Visa category is the most occurring category in the data set, and the least occurring is Discover. So that is one good importance of a Pareto chart. So this is based off of the frequency. So let's have another one that is going to be based off of the relative frequency. So we're going to call this a relative frequency Pareto chart. So again, we're going to have the categories on the horizontal axis, and the frequencies will be on the relative frequencies will be on the vertical axis. So over here, I'm going to have the relative frequencies. And then down here, I'm going to have the categories. Again, I'm going to present this in order from largest relative frequency to smallest relative frequency. So again, I'm going to have Visa. I'm going to have MasterCard, followed by American Express, and then followed by Discover. All right, so I'm going to label the vertical axis. So the largest relative frequency is 0.46, and the smallest is 0.14. So I'm going to label the vertical axis from 0 to 0.5 at intervals of 0.1. So I'm going to have here 0. I'm going to have 0.1 right here. I'm going to have 0.2, 0.3, 0.4, and then 0.5. So on this axis, we have the relative frequencies. So now, for the category Visa, the relative frequency is going to be 0.46. All right, so that is approximately 0.5 to 1 decimal place. So I'm going to have a rectangle. So 0.46 should be somewhere close to 0.5. So somewhere here, I'm going to have a rectangle that corresponds to the relative frequency of that category. So I'm going to have a rectangle on top of V. And then a MasterCard has a relative frequency of 0.22, which is going to be a little bit above 0.2 right here. So I'm going to have another rectangle corresponding to 0.22 on top of the MasterCard category. And then American Express has a relative frequency of 0.18. So I'm going to have a rectangle on top of American Express that corresponds in height to 0.18. 0.18 should be somewhere below 0.2. So I'm going to have a rectangle right here. And then lastly, we have Discover with a relative frequency of 0.14, which should be, again, below 0.2, closer to 0.1, so somewhere here. All right, so this becomes a relative frequency Pareto chart. So this is a relative frequency Pareto chart. So this is how we construct a relative frequency Pareto chart. Are there any questions about this? Questions?
No.
Thank you.
All right, good. As you can see, you can clearly see that both charts are the same. It's just like relative frequency bar graph and frequency bar graphs. They're exactly the same. The only thing that differs here would be the vertical axis. On this one, we got the relative frequencies, and here we have the frequencies. All right, that's the only difference. Everything else should be the same. All right, so we have here the frequency Pareto charts for the critical data. We've already constructed this, and I also constructed the relative frequency Pareto chart. Now let's talk about horizontal bar graphs. So a bar graph can be presented in a vertically manner or a horizontally manner. So we have vertical bar graphs and horizontal bar graphs. So these ones we have up here, these are vertical bar graphs. Now we would see what a horizontal bar graph is all about. So the reason why we sometimes prefer to use horizontal bar graph is because sometimes in the data set, the names of the categories might be a little bit too long. So when this happens, it might be convenient to make use of a horizontal bar graph instead of a vertical bar graph. But everything, I mean, they are both the same, just that one is horizontal and the other is vertical. So if you look at this example right here, so this is a data set. This bar graph represents a qualitative data, and in this data set, the data presents the different sectors, different employment sectors for U.S. residents. So if you look at the first category here, which is farming, forestry, and fishing, the second category is manufacturing, extraction, transportation, and crafts. And then we got managerial, professional, and technical, and then sales and office, and then other services. So as you can see, the names of the categories are pretty long. So it is convenient to make use of this horizontal bar graph. So here, in a horizontal bar graph, instead of looking at the height, we're looking at the length of each rectangle. So one key difference that I want you guys to note here is that in a horizontal bar graph, the different categories are on the vertical axis. And then the frequencies or the relative frequencies are going to be on the horizontal axis, unlike the vertical bar graphs. In a vertical bar graph, the frequencies or the relative frequencies are on the vertical axis, and then the categories are on the horizontal axis. So this is one big difference that exists between a horizontal bar graph and a vertical bar graph. And also in a horizontal bar graph, the length of each rectangle would correspond to the frequency or relative frequency of that category. So here we can also have relative frequency horizontal bar graph and a frequency horizontal bar graph. So this example right here is an example of a relative frequency horizontal bar graph, simply because if you look at the values on the horizontal axis, these are all decimal numbers. So this represents proportions. These are all proportions. So because they are proportions, they are all relative frequencies. So, and this makes this graph a relative frequency horizontal bar graph. So, for example, if you take the first category here, the relative frequency should be somewhere around here, closer to 0. And the next category, the relative frequency is right here, 0.2. So about 20% of US residents are employed in this sector. That is the manufacturing, extraction, transportation, and the craft sector. So that is what this bar graph represents. It represents the different types of service areas where US residents are employed. So this is an example of a qualitative data. And again, you can see that there's space left between each rectangle. So do not forget about that. All right, so for this particular category, so the relative frequency should be somewhere right here between 0.3 and 0.4. So let's say between 0.35 and 0.4. That should be around, let's say, 0.37. So approximately 37% of US residents are employed in this sector right here. So this plays the exact same role that a vertical bar graph plays. It allows us to organize and summarize data. So this is preferred when the names of the categories are pretty long. Is that okay? Any questions?
No.
All right,
No, thank you.
great. Let's move on to another kind of graph. We call this a side-by-side bar graph. So again, this is also a very important graph that we use to organize and describe qualitative data. So a side-by-side bar graph allows us to compare two or more qualitative data sets that have the exact same categories. So what we are doing here is we are simply combining the bar graphs of two different data sets together on one graph. That's what we are doing. And the reason we are doing this is because both data sets have the exact same categories. So this example here represents the number of active users for different social media platforms. And the social media platforms are Facebook, Gmail, Instagram, LinkedIn, and Twitter. So as you can see, this represents the number of users in the year 2017 and then in the year 2018. So whenever you have a side-by-side bar graph, when you construct a side-by-side bar graph, you need to have this information here on the side of the graph. This information is what we call the key to the graph. So this allows us to understand what each rectangle represents. As you can see, the small boxes that you see beside the years are of different colors. So the one for 2017 has kind of a purple color, and the one for 2018 has kind of a gray color. So this means that if you go to the graph, the rectangle that has the purple color would be for the year 2017, and the one that has the gray color will correspond to the year 2018. So for example, if you consider the first two rectangles here, The very first rectangle has a purple color, the first one right here. It has a purple color. So this simply means this rectangle represents the number of users for this social media platform, Facebook, in the year 2017. So in 2017, Facebook had approximately 2,100 users. That's what it means. But the other rectangle that is of gray color represent the number of users for Facebook in the year 2018. So in 2018, the number of users increased from about 2,100 to approximately 2,300. So here we can easily compare the data sets in the year 2017 and 2018 easily because we have put them together on the same graph. So this graph allows us to easily compare two or more data sets that have the same categories. And the categories, like I said, are the same for each year. They are the same social media platforms in both years. So for Gmail, for example, in the year 2017, Gmail had about, let's say, about close to 1,000 users. And then in the year 2018, it increased to about 1,500 users. So you can easily see what is going on by looking at this side-by-side bar graph. So it allows us to easily compare the two data sets. All right. So are there any questions on this?
No.
All right. And by the look of this graph, you can also tell which social media platform had the most number of users and which social media platform had the least number of users. That is also another importance of this graph. All right. Now let's talk about pie charts. Pie chart is also a very good tool that we can use to organize and describe qualitative data sets. What do we mean by a pie chart? A pie chart is just an alternative to the bar graph for displaying relative frequency information. So a pie chart simply represents a relative frequency distribution. So mostly it is used to represent a relative frequency distribution. So it's just a graphical representation of a relative frequency distribution. So a pie chart is a circle which is divided into sectors. And the relative sizes of the sectors match the relative frequencies of the categories in a qualitative data set. All right, so for example, let's say we have this circle right here. So I'm going to draw a circle right here. So every circle must have a center. So this is the center of this circle. So the path around the circle, that is what we call the circumference of the circle. So if I draw a line from the center to any part of the circumference, that line is what we call the radius. If I draw another radius, then I have a portion here, this shaded region, that is enclosed by the two radii and then a portion of the circumference. So this portion of the circumference, this is what we call the arc. So this shaded portion is enclosed and surrounded by two radii and an arc. So the shaded portion is what we call a sector. So a sector of a circle is just a portion of the circle that is surrounded or bounded by two radii and an arc. So a pie chart simply ensures that each category in the data set is represented by a sector of the circle. So this sector here is going to represent a category in the qualitative data set. So whenever you have data that has been organized as such, then this is going to be referred to as a pie chart. All right. So, and the size of the sector would also correspond to the relative frequency of that category. So for example, if a category has a relative frequency of 0.25, then the sector that corresponds to that category must take up about 25% of the circle. So that is how we construct pie charts. All right, so with that being said, let's see if we can construct a pie chart for the credit card data set. So I'm going to have the relative frequency distribution for that data. So I'm going to have here the credit cards and then the relative frequencies. Like I said, a pie chart is based off of relative frequencies. So I have MasterCard, Visa, and then we got here American Express, and then Discover. So the relative frequencies are 0.22, 0.46, and then 0.18, and then 0.14. All right, so I want to construct a pie chart for this relative frequency distribution. So the first step is to draw a circle. I'm going to have a circle right here. And then this is the center. So you can start from the smallest to the largest or from the largest to the smallest. I usually prefer to start from the largest relative frequency and I go all the way down to the smallest relative frequency. So the largest relative frequency here corresponds to the Visa card. So that means this category would occupy about 46% of the circle. So I'm going to have a sector. I'm going to draw a radius right here. I'm going to have another radius right there. So this portion here represents the Visa category, and that is about 46% of the circle. So the next largest relative frequency is 0.22, and that corresponds to MasterCard. So 0.22, I would say, would be this right here. So this is, that is pretty small. So let me see if I can enlarge that. All right, so 0.22, let's suppose this is 0.22. So this is the MasterCard category, and this corresponds to 22% of the data. And then the next largest is going to be American Express, 0.18. So this is going to be, pardon my drawing. So this is American Express, and that corresponds to 18% of the data. And then we have Discover here, which is 14%. All right. So again, you can see each sector here represents a category, and the size of the sector should match with the relative frequency of that category. So this is how we construct pie charts. It is easy to do this. So you do not have to, if on the exam I ask you to construct this, you do not have to draw it to perfection. It does not have to be perfect. All I need to say is this all I want to say is that the sectors correspond to the different relative frequencies. The size of the sectors should match with the relative frequencies. All right. Any questions on this?
No.
No.
All right, good. So now this is what we have for the pie chart. So this is what we just constructed up there. So as you can see, each sector corresponds to a category and the size corresponds to the relative frequency. So here we have some colors to distinguish these categories. All right. So now let's see if we can answer some questions. So let's see. I want you guys to, we're going to read this problem and I would want you to type your answer in the chat. All right. So the bar graph represents, or the bar graph presents the areas of the 6 largest islands in the world. So the islands are Greenland, New Guinea, Borneo Island, Madagascar, Baffin Island, and Sumatra. So these are the islands on the horizontal axis right here. So based on this, you can already tell that this is a qualitative data because these are all non-numerical. On the vertical axis here, we have the area of each island in thousands of square kilometers. All right, so let's see if we can use this bar graph. So this is going to be a frequency bar graph. So let's see if we can use this to answer the following questions. So based on the bar graph, which island is the largest in the world? Can you type your answer in the chat? What is the largest island? So everybody is saying Greenland. That is correct. Good job. So if you look at Greenland, as you can see, the rectangle that corresponds to Greenland has the largest height. That is the tallest rectangle. So that means the frequency for this category is going to be the largest amongst all frequencies. So therefore, that is going to make this island the largest in the world. So the largest island is going to be Greenland. So this is very easy to see from the bar graph. Now the next question, someone says that Madagascar and Baffin Island together are larger than New Guinea. Is this correct? Can you type your answer in the chat? Is that correct? So Stacy says yes. Kenna says yes. Isabella said yes. Trip said yes. Nicole said yes. All right, so that is correct. Actually, you guys are doing an amazing job. So if you look at the graph, so Madagascar is right here, and Baffin Island is right here. So if we sum up the areas of these two islands, obviously this should be larger than the area of New Guinea, right? That is very easy to see. So that means the answer to this question should be just yes. All right, the next question, approximately how large is Borneo Island? Can you guys type your answer in the chat? So Trip says 750,000. Stacy says 750. Isabella says 750. Nicole says 750. All right. So the answer is going to be 750,000 square kilometers. So remember, if you tell me it is 750, that is actually wrong. It is not correct. Because if you look at the vertical axis, it says that these values are in thousands of square kilometers. So it cannot just be 750, right? So it should be 750,000 square kilometers. Right? So Borneo Island here corresponds to a frequency of 750,000 kilometers. So this should be 750,000 square kilometers. Does that make sense to everybody?
Yes.
All right, so please make sure you always pay attention to the little details. This is very important. If this were to be a test, all those who said 750 would have gotten this wrong. So make sure you pay close attention to all the little details, okay? All right, so let's look at the next question. Approximately how much larger is New Guinea than Sumatra? Can you type your answer in the chat? How much larger is New Guinea than Sumatra? So Trip says approximately 400,000 square kilometers. Anybody else? Alan says 250,000. Stacy says 253,000 square kilometers. All right, so Trip, it is not 400,000. It's going to be approximately 250,000 square kilometers. So all those who are close to 250,000 that would be right, because it's just an approximate value. So if you're a little bit off the 250,000, I will give it to you on an exam. I'll give you the full credit. So let's look at the graph. So what this question is simply asking us to do is to determine the difference in the area of New Guinea and that of Sumatra. That is all what we have to do. So New Guinea is right here. It is approximately 750,000 square kilometers. And Sumatra is approximately 500,000 square kilometers. So if you subtract 500 from 750, that should give us approximately 250,000 square kilometers. Does that make sense to everybody? Is that clear to everybody? All right, good. All right, so now let's look at the next question. So this is going to be our last question for tonight. After this, we should be over with this section. All right. So the CBS News or New York Times poll asked a sample of people the following question. Do you think things in the United States 5 years from now will be better, worse, or about the same as they are today? So this poll was used to gather information from some people. So we surveyed a group of people and we asked them the question, do you think things will be better in the United States 5 years from now? Or would they be worse, or would they be about the same? So this is a pie chart that represents the results of this survey. So the survey, the results were organized, or the data set was organized in the pie charts. And the reason why we use a pie chart is because this is a qualitative data set. Because the categories in this data are going to be better, worse, and about the same. These are all non-numerical categories. So if you look at the pie charts, about 39% responded that things will be better 5 years from now. And then 4% did not respond to the survey. About 19% said things are going to be about the same. And then about 38% responded that things are going to be worse. So now we want to use this pie chart to answer the questions that follow. So the first question is, which was the most common response? Can you type your answer in the chat? All right, so obviously, the most common response here will be better because that is the response that has the largest sector and also has the largest proportion, 39%. So this is the largest proportion out of all the proportions here. So the most common response was better in this survey. The next question, what percentage of people said that things would be the same or worse in 5 years? And so, can you guys type your answers in the chat? What percentage said that things would be the same or worse in 5 years? 57%, Trip says 57%. Anybody else? Kenna says 57. All right. So can somebody explain briefly why we have 57%? You can type in the chat. Can someone give us a brief explanation why it is 57%? That's correct, Nicole. You added 2. That's very correct. Good job. All right. So what you have to do here is simply add the proportions of those who said things are going to be the same and the proportion of those who said things are going to be worse. So you're going to add these 2 percentages right here. So this plus that. So if you add it up, you're going to have 57%. So that is pretty easy to do. All right, so the next question, this is a true or false question. So more than half of the people surveyed said that things would be the same or better in 5 years. Is this true or is this correct? Can you type your answer? So the answer is true. So Stacy says true. Trip said true. That is correct. So again, you would have to add the proportions of those who said that things are going to be the same and those who said that things are going to be better. So you're going to add 39% and then 19%. So that should give us about 58%, right? And that is obviously more than half of the people who were surveyed. So that means the answer to this question will definitely be true. Does that make sense to everybody? Any questions? So I should expect you guys to get this kind of questions. Nicole, do you have a question? Okay, all right, good. So I should expect you guys to solve similar kind of problems on the exam. So this is pretty easy to do. There's no really some serious mathematics involved here. So again, if you have any questions, feel free to send me an email. So this is where we're going to end section 2.1. So hopefully we can meet in person next week so that we can go over section 2.2. So again, I would like to remind you, for those who joined in late, on this Sunday, you have the first project that is due this Sunday. So I am allowing you guys to work on the project individually if you do not have a group as of now. So you're welcome to work on that project by yourself and submit it on Sunday. And if you happen to have a group and you work on the project as a group, again, make sure each member in the group should submit the project individually in Canvas. So every single one should submit a project through Canvas. All right. And also, I want to remind you, next Monday, you have your first homework. That will be homework on chapter 1. That will be due next Monday at 11:59 p.m. in Alex. So that homework is going to cover sections 1.1 through 1.4. So please make sure you start working on that when you have some time. All right. Are there any questions at this point? Any questions for me?
No, thank you.
All right, good. You're welcome. So the lecture has been recorded, so I'm going to post it in Canvas. So I'll let you know when I post the recording. So you're always welcome to come back and watch it later if you want to. All right, on that note, I'm going to end the lecture. So you guys should have a great night, a good weekend, and I'll see you guys next week, hopefully, in class. All right?